Hi. So apparently the last recording stopped because there is a limit on the number of strokes uh, I can use on the whiteboard, on the Zoom whiteboard. So anyway, let's get started. So the next concept is polygons. So in polygons, the first concept is interior angle of n-sided polygon. So which is given by n minus 2 into 180 by n, where n is the number of side. The next concept is number of diagonals of n-sided polygon. Of course, these are regular polygons, which is n into n minus 3 by 2, where n is the number of sides. The next concept worth remembering is, let's say we have any regular polygon. Uh, let's say we have this hexagon. So no matter what the figure is, let's say octagon भी draw कर लेते हैं तो let's say 1 second. So 1, 2, 3, 4, 5, 6, 7, 8. Anyway, so let's say this is an octagon and we join all its diagonals. So in there will always be a meeting point of diagonals. Let's say this particular point. So this in hexagon also, if we join this, then this, then this. So let's say, or rather, okay. So here is the concept. So let's say we draw a regular polygon, be it a hexagon, and we draw a center, and we divide the particular regular polygon into equal parts, depending on the number of sides it has. For example, इस हेक्सागन को हमने 6 इक्वल ट्राइंगल में डिवाइड किया, इस ऑक्टागन को हम लोग चाहे तो 8 इक्वल ट्राइंगल में डिवाइड कर सकते हैं. सो ये जो एक एक ट्राइंगल है, यहाँ पे ये, यहाँ पे ये, सो इस ट्राइंगल का भी कुछ प्रॉपर्टीज है. फॉर एग्जांपल ऐसा एक ट्राइंगल है. सो इफ वी ड्रॉ एन एंगल बाइसेक्टर हियर. ओके, सो लेट्स हम एक इस यहाँ पे एक मीडियन ड्रॉ करते हैं. सो दिस लाइन विल बी, फर्स्ट ऑफ ऑल, सॉरी, हम लोग ये जो लाइन है ये लेट्स से आर है. दैट मीन्स हम लोग अगर इसको इनकम्पास करके एक सर्कल ड्रॉ करते हैं, then this will be the r. Okay, this will be the in radius of this particular polygon, and this r will also be the angle bisector of the polygon. Okay, that means this is 180 by n, where n is the number of sides. This is also 180 by n. This is a by 2. This is a by 2. That means this is also the median. Okay, and this, ladies and gentlemen, this is capital R. Okay, so these are the few things to be remembered in polygon. Then we will remember some stuffs which are dedicatedly for hexagon and octagon. In hexagon, the area is 6 into root 3 by 4 a square. Then we have total 9 diagonals in a hexagon. Uh, 6 diagonal, 6 of them are of root 3a length, and 3 of them are of 2a length, है ना? Then we have octagon. Now in octagon we have 3 type of diagonals. Just in case of hexagon we had 2 type of diagonals. In octagon we have 3 type of diagonals. First is smaller ones, a root 2 plus root 2 length. Second is medium, which is a 1 plus root 2 length. And third one is large, which is a 4 plus 2 root 2 length, where a is the length of each side of the octagon, and area of any given octagon is 2a square 1 plus root 2, है ना? 2a squared into 1 plus root 2, where a is the length of side of a diagonal. The last topic that we are left with which is mensuration. Okay, so in mensuration, we have many scary looking formulas, but we will try to simplify them as much as possible. Okay, so uh, in mensuration, we have 2 types of figures. One is prism and second is pyramids. So prism can be categorized as, let's say, any type of symmetrical figure like uh, cube, we have cuboid, we have cylinder, and etc. Now, area, yeah, so it is symmetrical. So, volume of any prism will be given by area of base into height. Then lateral surface area will be given by lateral surface area is the area of the surface without considering the bases, okay, which is perimeter of base into height, and then we will have total surface area, which is lateral surface area plus 2 into area of base. Okay, any figure basically which is symmetrical. So now let's come to pyramids. Now in case of pyramids, pyramids are defined as any figure 3D or 2D figure forming an apex, right? फॉर एग्जाम्पल ये हो गया एपेक्स, लेट्स से ये एक कोन है, तो ये एपेक्स बन गया, देन राइट, सो दैट्स बेसिकली इट। को अब इसका बेस कुछ भी हो सकता है, राइट? फॉर एग्जाम्पल ये हो गया, ये 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 भी एक पिरामिड है। एनीवे हम जल्दी से फॉर्मूले पे आते हैं। सो इट्स वॉल्यूम विल बी गिवन बाय 1/3 into area of base into height. Then we have lateral surface area, which is half into perimeter of base into height, sorry, slant height into slant height. Slant height is this height. Then we have total surface area, which is LS, lateral surface area plus area of base. The next important figure is sphere. So our Earth is a sphere, right? Its volume will be given by 4/3 pi r cube. Its curved surface area will be equal to its total surface area, which is equal to 4 pi r square. Then we have hemisphere. इसका volume is 2/3 pi r cube. इसका curved surface area is 2 pi r square और इसका total surface area is 2 pi r square plus pi r square. The last thing to learn in uh, mensuration is cone versus frustum. Cone versus frustum. So there are some uh, visible differences between cone and frustum. So let's try to uh, write them up one by one. So we all know what is cone. Cone is basically any triangular figure with a base, and frustum is basically any such figure which is cut from the top, and the figure somewhat becomes like this, like a funnel, right? So in this case, mm, this is L, this is height, and this is radius. And in this case, this is small radius, this is height, and this is capital radius, and this is slant height. So in cone, we have, of course, L square equals to H square plus R square. Curved surface area is given by pi r L. Total surface area is given by pi r L plus pi r square, and volume is given by 1/3 pi r square h. In first term, we have L square, which is equal to h square plus r minus r square, right? CSA is given by pi r plus r into L. Total surface area is given by pi r plus r L plus pi r square plus pi capital R square, and its volume is given by 1 by 3 pi r square plus r square plus rr into h, height. So this ends our revision session. So let's quickly try to recap what we learned and which areas we learned. So first of all, we saw in arithmetic circular track where meeting for the first time is where there are two concepts for meeting at the first time. पहला तो स्टार्टिंग पॉइंट में जब अपन मीट करते हैं तो उसका होता है रिलेटिव स्पीड कंसेप्ट चलता है, और सॉरी स्टार्टिंग पॉइंट पे जब मीट करते हैं तो एलसीएम ऑफ टाइम टेकन, इंडिविजुअल टाइम टेकन टू कवर वन पार्टिकुलर लैप, और जब कहीं भी मीट करते हैं तो रिलेटिव स्पीड का कंसेप्ट चलता है. सेकेंड इज मीटिंग फॉर द nth टाइम. मीटिंग फॉर द nth टाइम इज बेसिकली n इंटू मीटिंग फॉर द फर्स्ट टाइम. लेट्स से मीटिंग फॉर द फर्स्ट टाइम में 10 सेकेंड लगता है तो मीटिंग फॉर द फिफ्थ टाइम में 50 सेकेंड लगेगा. नंबर ऑफ डिस्ट्रिक्ट मीटिंग पॉइंट्स. डिस्ट्रिक्ट मीटिंग पॉइंट्स जब सेम डायरेक्शन में चलेंगे तो माइनस हो जाएगा, और जब अपोजिट डायरेक्शन में चलेंगे तो प्लस हो जाएगा. और डिस्टिंक्ट मीटिंग पॉइंट बेसिकली हम जो स्पीड के रेशियोज दिए होते हैं उनको मिनिमम फॉर्म में लाके, दैट इज को प्राइम फॉर्म में लाके, फिर उनको लेट्स से देन उनको काउंट करते हैं नंबर ऑफ डिस्ट्रिक्ट मीटिंग पॉइंट्स. देन वी हैव सर्कुलर ट्रैक फॉर 3 पीपल, जिसमें हम लोग दो दो कॉम्बिनेशंस के 3 लोगों का डिस्टिंक्ट मीटिंग पॉइंट्स निकालते हैं और फिर उनका HCF निकाल देते हैं. देन वी हैव लीनियर ट्रैक where two people run infinitely between 2 points in a track. तो ऐसे केसेस में पहला मीटिंग पॉइंट जो होता है वो ट्रैक का लेंथ ही होता है, और दूसरा मीटिंग पॉइंट जो होता है फर्स्ट मीटिंग पॉइंट से सेकेंड मीटिंग पॉइंट का लेंथ जो होता है वो 2D होता है, राइट. देन वी लर्न एस्केलेटर. हमें दो इंडिविजुअल स्पीड दिए होंगे कि ए और बी बंदा थर्ड 3 मीटर पर सेकेंड और 1 मीटर पर सेकेंड की स्पीड से, सॉरी 3 स्टेप पर सेकेंड और 1 स्टेप पर सेकेंड की स्पीड से चलता है. एंड देन द नंबर ऑफ स्टेप्स दे took to climb a particular escalator upward और downward, ये दिया जाएगा. हम पहले निकालेंगे वहां से टाइम, और डिस्टेंस इज नथिंग, बेसिकली नथिंग बट स्पीड इनटू टाइम. सो टाइम निकाल के, और टाइम हम लोग कैसे निकालेंगे? टाइम नंबर ऑफ स्टेप्स बाय स्पीड, that is number of steps per second, total number of steps by number of steps per second डिवाइड करके हम लोग टाइम निकालेंगे, और टाइम इनटू फिर जो एस्केलेटर का स्पीड रहेगा वो सिचुएशन के हिसाब से प्लस या ऐड कर देंगे इंडिविजुअल स्पीड के साथ, और एंड देन वो दोनों इक्वेट कर देंगे. और वो इक्वेट क्या होगा? दैट इज बेसिकली एस्केलेटर स्टेशनरी पोजीशन में जब रहता है तब कितना स्टेप्स दिखता है उसमें, दैट इज व्हाट वी विल बी इक्वेटिंग. Then we straight directly come to algebra, where nth term of GP is ARn minus 1. Sum of GP is A bracket 1 minus Rn by 1 minus R. Then we have sum of infinite GP A by 1 minus R. Then we have HP, let's say A, B, C are in HP, then B will be given by 2AC by A plus C. Then we have a relation between AM, GM and HM, which is GM square equals to AM into HM. Then we learnt about difference AP, where sum of n terms is n plus 1 by 2. Sum of n square term is n plus 1, 2n plus 1 by 6. And n cube is n plus 1 by 2 का whole square. है ना? Then we have difference AP. Difference AP में अच्छा यही तो हमने याद किया अभी. Then we have telescope. Now telescope in numerator का formula है okay, so telescope in numerator का formula है 1 by n plus 1 into d. Then पहले का 4 टर्म, मतलब अगर जितना भी टर्म होगा उसका एक बढ़ा देंगे लास्ट से, माइनस 4 टर्म, दैट मीन्स कि जितना भी टर्म होगा लास्ट का एक बढ़ा देंगे लास्ट से. ओके, एंड वन n is basically number of terms in a slot, and d is the difference between first term of first slot and first term of second slot. Then we have telescope in denominator, where the formula is given by 1 by n minus 1 into d. n और d सेम रहेंगे, मतलब जैसे न्यूमरेटर वाले में रहते हैं, जस्ट दैट ब्रैकेट में जो रहेगा दैट विल बी 1 बाई, वो भी 1 बाई हो जाएगा, और एक एक टर्म घट जाएगा, पहले टर्म माइनस लास्ट टर्म हो जाएगा, राइट. और पहले टर्म का थर्ड टर्म या फिर जो लास्ट टर्म है वो चला जाएगा, और लास्ट टर्म में से जो पहला टर्म है वो चला जाएगा. Then we will have modulus, opening modulus. So mod x greater than k है, then x greater than k and x less than minus k. If mod x less than k है, then x lies between minus k to k. Then आता है हमारा logarithms, उसमें number of digits और leading zeros काउंट करने का एक ही तरीका है, that is characteristics plus 1. Then we have three discriminant conditions of a quadratic equation, that is d greater than 0, जहाँ पे दो distinct roots होते हैं और रियल होते हैं. देन d इक्वल्स टू 0, वेर दो रूट सिमिलर सेम होते हैं लेकिन रूट्स रियल होते हैं. एंड देन वी हैव d लेस देन 0, वेर d लेस देन 0, वेर roots are complex conjugates. Then we have when two equations, two quadratic equations have a common root, then the relation that is established between them is a1 b2 minus b2 c1, a1 b2 minus b1 a2 into b1 c2 minus b2 c1 equals c1 a2 minus c2 a1. Okay. When both the roots are common, then a1 by a2 equals b1 by b2 equals c1 by c2. Then we have two pair of linear equations. When they have no solution, then a1 by a2 equals b1 by b2. When they have one solution, then we have a1 by b2, a1 by a2 not equals b1 by b2. And when they have infinite solution, we have a1 by a2 equals b1 by b2 equals c1 by c2. Then we can also make perfect square from a given expression. अगर हमें a1x plus ax plus x square plus bx plus c दिया हुआ है, then we just in order to make it a perfect square, we have to add b by 2 का whole square and subtract b by 2 का whole square from that expression. Then we have conditions for a to the power b equals 1. तो तीन conditions यहाँ पे apply होते हैं. पहला condition is when a equals 1, then b can be anything. then we have b equals 0, then a not equals 0, and then we have a equals -1 and b is even, है ना? B is even. Then we have some common forms of functions. First is fx plus 1 equals to 1 plus fx by 1 minus fx. Okay, and उसका cyclicity 4 होता है. Then we have cyclicity 6 वाला function which is fx minus 1 plus fx plus 1 equals fx. उसका cyclicity 6 होता है. Then we have fx plus y equals to fx into fy. Then fx equals to a to the power x. And then we have x plus f1 by x equals to fx into f1 by x. Then fx equals to f1 plus minus x to the power n. Okay, so this completes our algebra. Then we came to what we call geometry. So geometry में first concept जो था कि number of triangles possible with two given sides, दो cases बनते हैं. उसमें पहला केस जब x is the largest side, then x less than the two other sides, and if the uh, among the two given sides, if the larger one is the larger side, then that will be less than x plus the other smaller side. Then if a number of obtuse angle triangle में हम निकालते हैं कैसे है, uh, when x is the largest side, then the condition is x square greater than the two given sides का square. Okay, and when and similar, there are the other cases similar to what I discussed in the first case. Similarly, for acute angle, the condition is x square less than the square of two given sides, where uh, x square is the largest side. And one more case will be followed by that, in which the one among the two given side will be the largest side. Then we straight away came to median. और अगर तीन मीडियन दिया होता है तो वहां से हम एरिया निकाल सकते हैं, which is 4/3 into area of triangle formed by three medians. Then we can the median का definition ही होता है जो कोई केवियन लाइन जो टू इक्वल पार्ट और टू इक्वल एरिया में डिवाइड करता है ट्राइंगल को. तीन मीडियन जब जो जिस पॉइंट पे मीट करते हैं उसको हम लोग सेंट्रॉइड बोलते हैं, और सेंट्रॉइड किसी भी मीडियन को 2:1 में डिवाइड करता है. जो कोई राइट एंगल ट्राइंगल होता है उसके मीडियन और साइड के बीच में एक रिलेशन होता है, दैट इज दो मीडियन का स्क्वायर जो नॉन हाइपोटेन्यूज साइड में ड्रॉ किए हुए हैं इक्वल टू 5 into that median का स्क्वायर which is drawn into hypotenuse, है ना? Then अगर दो मीडियन perpendicular to each other है, then those sides, वो वाले साइड जिसमें दो मीडियन ड्रॉ किए गए हैं, उन दोनों का स्क्वायर विल बी इक्वल टू दैट साइड का स्क्वायर 5 into दैट साइड का स्क्वायर जहाँ पे कोई मीडियन ड्रॉ नहीं किया गया. देन वी कम टू एपोलोनियस, जहाँ पे ए बी स्क्वायर प्लस ए सी स्क्वायर इक्वल्स टू 2 into होल ब्रैकेट ए डी स्क्वायर प्लस डी सी स्क्वायर. मतलब दो नॉन मीडियन वाले साइड का स्क्वायर इक्वल्स टू 2 into मीडियन का स्क्वायर प्लस हाफ ऑफ जो मीडियन जो साइड में ड्रॉप हुआ है उस वाले साइड का हाफ का स्क्वायर. ओके, एंड देन वी हैव 3 into all the side का square equals to 4 into all the median का square. Then we come to in radius, where r is given as area by semi-perimeter for any triangle, a by √2√3 for equilateral triangle, ai by id equals to b plus a by c. Then we have r equals to a plus b minus c for right angle triangle, and BIC equals to 90 plus A by 2. Then we have value table. ये तो खैर क्या ही याद होगा, मतलब इसको तो then we have angle bisector theorem which is AB by AC equals to BD by CD, है ना. Then we have rhombus where d1 square plus d2 square equals to 4a square. Then we have r equals to in circle of a in radius of a rhombus is d1 d2 by 2 into root over of d1 square plus d2 square. Then we straight away come to circumcenter where r capital R equals to ABC by 4a. Then we have capital R equals to 2 into small r. For equilateral triangle, distance between capital R and small r is capital R square minus 2 into capital R into small r का whole root. For right angle triangle, capital R equals to hypo by 2. Area of right angle triangle whose capital R and small r is given is A equals to small r square plus 2 into small r into capital R. Then we have trapezium. So trapezium का जो line जो लाइन मिड पॉइंट ऑफ नॉन पैरेलल साइड को ज्वाइन करती है दैट इज sum of parallel side by 2. Then we have area of median, area of trapezium which is half into sum of parallel side into height. Then we have, if we draw diagonals in a trapezium, then it the two of them will be equal and the three of them will be in GP. All four of them will be in GP. Then we have, let's say, altitude, where uh, if two altitudes are given, then the third altitude will lie between h1 by h1 h2 by h1 plus h2 or h1 by h1 h2 by h1 minus h2. Then we have something called Viviani's theorem, जहाँ पे कोई एक पॉइंट होगा इक्विलैटरल ट्रायंगल में के अंदर जहाँ से तीन परपेंडिकुलर ड्रॉ किए जाते हैं. तो तीनों परपेंडिकुलर का लेंथ मिला के एक क्या बोलते हैं उसको, अ, एक हाइट का लेंथ होता है उस पर्टिकुलर इक्विलैटरल ट्रायंगल का. देन वी हैव polygon. So in polygon, interior angle of n-sided polygon is n minus 2 into 180 by n. The number of diagonals in an n-sided polygon is n minus 3 by 2. Then we have we can evaluate the triangle that is formed by dividing the a particular uh, regular polygon number of into its number of bases, and in that case the uh, small r will be uh, its median as well as its angle bisector as well as its height, and the angle, each of the bisected angle will be 180 by n, where n is the number of sides, and the sides of the triangle will be isosceles, which is capital R. Then we have, uh, in case of hexagon, we have six diagonals of root 3a length and three diagonals of 2a length. Area of regular hexagon is root 6 into root 3 by 4a square. Then we have octagon where we have three type of diagonals. Smaller diagonals are of a root over of 2 plus root over of 2 length. Medium diagonals are of a 1 plus root 2 length. And large are a root over of 4 plus 2 root 2 length. Area of octagon is given by 2a square bracket 1 plus root 2 bracket close. Then we directly came to mensuration. So in mensuration, we have basically three type of figure. First is prism. Volume of any prism is area of base into height. Lateral surface area is perimeter of base into height. Total surface area is lateral surface area plus 2 into area of base. Prism is basically any figure which is symmetrical, any 3D figure which is symmetrical. Then we come to pyramid. Pyramid is any figure with pointed side, and volume of any pyramid is 1 by 1/3 area of base into height. Lateral surface area is half into perimeter of base into slant height, and total surface area is lateral surface area plus area of base. Sphere, we have sphere. So volume of sphere is 4 by 3 pi r cube. Curved surface area is equal to total surface area equal to 4 pi r square. Hemisphere, hemisphere in case of hemisphere volume is 2/3 pi r cube. Curved surface area is 2 pi r square, and total surface area is 2 pi r square plus pi r square. That means 3 pi r square. Then we have some differences between cone and frustum. In case of cone, slant height is equals to h square plus r square. Curved surface area is pi rl, and total surface area is pi rl plus pi r square. Volume is 1/3 pi r square h. In case of frustum, slant height square equals to height square plus capital R minus small r ka square. Curved surface area is pi into small r plus capital R L, that is slant height. Total surface area is pi into small r plus capital R bracket close L plus pi r square plus pi capital R square. Volume of frustum 1 by 3 pi into height bracket open small r square plus capital R square plus small r into capital R bracket close. So that ends our revision. So I hope if anyone is watching it, it will be beneficial for them. So thanks a lot for viewing.